Welcome to today's webinar, Best Practices for Building a Data Lake with Amazon S3. Our presenters today are Raul Barsha and Susan Chan. Raul is a Partner Solutions Architect, and Susan is a Senior Product Manager for S3 at AWS. Today with us we also have Manjit Chayal, John Mallory, Roy Benalta, Drew Meyer, and Joe Disher. They will serve as our webinar moderators and will engage with you and answer your questions throughout the presentation while the presenters present. Raul and Susan, welcome. The floor is now yours.
Thank you, Ryan. So as Ryan mentioned, today we are going to talk about best practices for building a data lake with Amazon S3. Joining with me today, as Ryan mentioned, is also Susan, and she will talk about the best practices with Amazon S3. So before we get started in talking about best practices, I think it's very important that we all come to a same notion of what a data lake is. Now, to look or to define a data lake, we have to go back in history and look into how did the evolution of data lake happen over time. This slide, which was the genesis of when the database ruled supreme, or they were the one tool for everything you had to do, in which case you were capturing your online transactions into a database, which we used to refer to as online transactional processing systems, OLTP in short, and then extract, transform, and load data, or in short, ETL the data into data warehouse. Into this scheme of things, you require to define a schema or a format or how the data was going to be in your data warehouse. You knew what you had to extract, and you extracted the data set, transformed it into the fit into the schema you had defined into your data warehouse, and then loaded it into the schema. This was the classical case of where everything was defined in data warehouse, or it captured what we used to call as a single source of truth. As the systems grew, we all realized that there were a lot of logs, had a lot of information, and it made sense to combine that logs into the data warehouse to get more deeper analytics per se. For example, not only capturing transactions could tell you that how many users are making transactions, but logs would also tell you that what is the cost from the infrastructure perspective of the transaction happening within your company. So with logs also we did the same thing. We took the files, we transformed that to somewhat more complicated ETL process using scripts, using other such data integration tools, and let them into data warehouse again. This was the point, or this was the boundary where the idea of having a data warehouse load anything and everything was starting to being challenged by new entries such as Hadoop and streaming data sets such as IoT and clickstream events. And the Hadoop was basically led to, it was not just a single framework, but it was a very radical idea of how did you your data analytical and processing. And with streams, the idea was not to capture data at once a day or at a certain frequency, but it was, you can think of it as unbounded events which are just flowing through a constant stream. So the question which started to appear at that time was that what do we do with streams? Should we put that into a data warehouse? What role does Hadoop play? And while we were trying to answer those questions, if you realize that, as I mentioned, that Hadoop ecosystem was not just a Hadoop, but is a much bigger range of frameworks. For example, you can, on the left-hand side, you can see some of the popular frameworks which help you process your data sets, collect logs, collect streaming data sets, or even visualize those data sets, or for instances such as NoSQL databases like Apache HBase. And on the right-hand side, you can see the Amazon versions of those products which AWS provides as services. For example, Amazon EMR, which is managed Hadoop clusters, Amazon Redshift, which is a data warehouse, Amazon DynamoDB, which is a NoSQL database as such. So the question still remains that what are the roles these frameworks play into the entire ecosystem? And this is where the technology such as a data lake was starting to born, or the concept of a data lake started to take place. The idea behind a data lake was that rather than trying to define a schema in first data warehouse, you captured your data sets raw into something called a data lake. The idea behind data lake was a storage system which allowed you to capture all of these data sets raw. And then as and when you required it, allowed you to define a schema on read, which is the popular term in Hadoop versus a data warehouse where you define a schema on write versus schema on read. So you can think of data lake as a virtualization technology for data as such. And if you look into a data lake, it basically allows you to capture all the data sets from multiple sources and all of the sources into the format they are generated, and then I'll create a workflow on top of it, which could be a data warehouse, which could be a NoSQL database, or could be a search index or etc. For the brevity's sake, we just displayed a data warehouse example here. But is data lake just storing your data in raw format? That really is not what a data lake is. So what really is a data lake then? If you look deeper into data lake and you try to define what a data lake might be, it consists of at least 4 components. The first is which we have been talking about, which is collecting and storing your data sets. So you take your data sets being capable of collecting from multiple systems such as files, logs, events, and other systems, and being able to store that in the format they originate without doing any transformation on top of the data set. But just storing and collecting is not enough. You need to catalog and search, or you need to provide an ability for users to catalog and search. Catalog in the sense of you have metadata associated with the data sets, and search as in I can use those metadata, or I can use the business terms to find the relevant data set for my job or for my use case. The third case building on top of it is that while I can search the data set, it deals with whether I'm allowed to access the data set or not, which is basically saying that can I as a user saw the data sets which is sitting in a data lake. For example, a person working in payroll, should he be allowed to access the transactional systems or financial systems data sets? And such is the kind of tools you have to, or such is the kind of tooling one should definitely think about while working on a data lake. The API and the UI perspectives are making it easier for users to consume your data lake. You don't want to document all of this into a Wikipedia or internal documentation, but you want people to be able to automate in a DevOps kind of mindset. And this is the same philosophy which AWS takes for all of its services. For example, while we have our APIs, we have our SDKs, and we also have our console. So you can access any service we have via any of these methods and choose the right way of how you want to interact with that service. Let's take a deeper look into all of these components one by one. From a storage perspective, if you remember earlier that we mentioned, we gave you a picture of all the frameworks and all the AWS services into the umbrella called big data. So if you really think from a data lake perspective, at the center of that data lake perspective is Hadoop or HDFS, which allows you to store your data into a format, and then you have multiple frameworks which run on top of it, which allows you to access the data in a certain way or as per your requirements. For example, if you want fast access to data sets, you can run NoSQL databases such as Apache HBase or Cassandra. If you want to query your data sets, you can use SQL on Hadoop systems such as Impala, Hive, Presto, Spark SQL. If you want to process or compute something on the top of data sets, including things like machine learning algorithms, you could use frameworks such as Spark, Cascading, Pig, or multiple other data flow languages. And if you just want to run a search system, then you can have tools like Splunk or Elasticsearch, which allows you to build a search index on the top of the data, on top of the data set. And all of these data sets either leverage HDFS directly or they integrate with HDFS to allow you to build that ecosystem. But that definition of data lake is a bit different if you go back to the left side versus the right side kind of situation based on the frameworks. On AWS, Amazon S3 provides a platform for you to store all of your data sets. And then there are systems which can run on top of the data sets, similar to the way Hadoop interacts with other, or HDFS allows interaction with other data sets. For example, you could load your data using a single command into a Redshift cluster and start running your data warehouse workloads. You don't even need to create a cluster, you don't even need to load your data set with Amazon Elastic MapReduce. You can quickly create Elastic MapReduce clusters and start processing your data sets with one of those Hadoop frameworks by leveraging the data stored in S3 directly. Amazon EMR provides you the integration using EMRFS, which allows you to read data streaming from S3. Amazon Machine Learning, for example, allows you to build that framework or run a machine learning algorithms on top of data sitting in Amazon S3. Similarly, we have integration with DynamoDB where you can read data sets from S3 or load or backup data sets from S3. If you think about Amazon Glacier, which is an archiving system, long-term storage, Amazon S3 allows you to create policies by which you can move data sets from S3 into Glacier. And my colleague Susan will talk further about that when she talks about S3 in much more details later. But that's If you want to implement a data lake, then you have to look at Amazon S3 as a storage component on AWS and then build on top of that storage component as we go along. So let's look at some of the other components for the data lake, for example, catalog and search. To build a catalog and search, you could simply create a workflow. For instance, when your data has been uploaded to Amazon S3, it sends out a S3 event notification to which is connected to a AWS Lambda function. What it simply means is that the moment you put an object in S3, it leads to a notification which triggers a AWS Lambda function. And the Lambda function could do multiple things. For example, it can first index your data set into a DynamoDB. When we say index, in this case, you're just creating a few tags around the data sets into DynamoDB, or a few definitions to say that what the data set has been loaded. For example, you can say that the file which was just uploaded into S3 has a collection of all the transactions done in the previous day, all the business transactions done in the previous day, which contains the fields such as amount of transaction, date of transaction, type of transaction, and other aspects. So that way users can now search your data sets on tags and figure out that where the object or where the data set resides in S3. If you want to allow a deeper search, or if you want to provide a feature to do a deeper search based on the values in the data set, you could also extract certain feeds from the data set. For example, let's say transaction country, and you can index that using a search and index technology such as Cloud Search or Elasticsearch. So in that way, now users can not only find that where are the objects in S3 which contain all the transactions, but they can also go and search saying that show me all the transactions which originated from Seattle and United States on a given day, for example. And that allows you to search in a much more semantic way within your data set. So that could be just an implementation of catalog and search on AWS in a totally serverless manner, in which case you're not really running any servers, but you're just building these components using our services, using AWS services to provide simple metadata and search capabilities. Let's look into the next part, which is entitlements. And entitlements not only just deals with access control, but encryption and data protection is a very integral part of it. The reason it is a very integral part of it is because using encryption, if you encrypt your data, then you can control who has access to the encryption keys, thereby implementing a access control mechanism on top of that encrypted data sets. We provide encryption using Cloud HSM, which is a dedicated tenancy SafeNet Luna HSM hardware module. And we also have AWS Key Management Service, which automatically allows you to kind of create keys, and it integrates with other services such as Redshift, S3, and EBS. Or you could also use the AWS server-side encryption, in which case we manage all the infrastructure for your keys and encrypt data transparently to your workload. All you have to do is ask for the feature to the data to be encrypted. For example, in Amazon S3, you could just enable server-side encryption, and at that point in time, your data will be encrypted within Amazon S3 automatically without you worrying about any sort of keys or key management feature sets per se. So all of these encryption provide a different level of control or different levels of options you have. But as we mentioned that if you encrypt your data sets, for example, one of the things you can do is by controlling user access to the encryption keys used to encrypt the data sets, you also can model an entitlement access control or access control per se. For example, you could use IAM to generate a temporary credentials which provide access to a customer data key, which was used to encrypt the data sets. And now when you read the data sets, you could say that this user is allowed to access the encryption key for a certain period of time as long as it's coming from the right role or coming from the right profile in IAM. You give him that temporary key to read the customer data sets so he can encrypt the data set in S3. If he don't have access to the encryption key, the data sitting in Amazon S3, while he may see the data set, but he won't be able to use it because it's encrypted. And that way you could simulate some form of access control while building your data lake on Amazon S3. The last part being API and UI. And in the API and UI, all here we are doing is striving to provide an easy interface for users to query the catalog, to access the data sets, and even to expose the search or the search index if we have built that. For example, this could be again implemented in a simpler manner using API Gateway, which is connected to a Elastic Beanstalk hosted application. So users could either access the API gateway directly, which is providing the REST services, for example, to search, query, define, access your data sets, find a data lake, and the UI is implementing the same thing on top in a user interface manner. But connected to, for example, the API gateway could be a simple Lambda functions, which when a user calls those APIs, it just goes query the metadata index and returns the data set location. For example, let's say that we have a very simple schema in DynamoDB where we say the business tags defined by the location of the object in S3. For example, business tag means the type of data sets, which is transactional, time period, which will tell you that whether it's for a month, which month, or which year it is. And now you could have an API which might users say that, give me the transactions which occurred in the month of August in 2016. At that point in time, your Lambda could just query the metadata in DynamoDB and return the object name in S3, which contains that contains that data set, for instance. And that way, without using any sort of heavy code or heavy implementation, you can simply build a very simple API and UI architecture on top of a data lake. And all of these will provide you a lot of value while constructing your data lake, because at the end of it, data lake is not just storing your raw data, but it's also about helping your teams be agile, helping your teams be easily access the data set, in a manner they deem appropriate for their use case. So if you put all of this together and if you combine everything we talked about, this is what a data lake on AWS in a very simple form may look like, where you're storing all of your data set, collecting it using Kinesis streams, Glacier, Snowball, and putting that all of the data set in S3. And then you have a very simple search and metadata index in Dynamo and Elasticsearch or Cloud Search, connected to IAM, connected to key management system or our STS or security token servers. And on top of that, you have API gateway and Elastic Beanstalk to hold the APIs and to build the API and the UIs per se. And this could provide a very functional, very effective data lake implementation on top of AWS. With that, I think we all have come to probably a common definition of what a data lake is. And we would like, now I would like to invite my colleague Susan to focus or to talk about best practices or how Amazon S3 plays a role in building your data lake on AWS. Thank you, Susan.
Thank you, Rahul. Good morning, everyone. So as Rahul mentioned, Amazon S3, if you're when you're building a data lake in AWS, Amazon S3 is where the storage component will reside. It is so let's go through kind of why Amazon S3 would be a good choice for your storage part of your data lake. Amazon S3 is very durable. It is designed for 11 nines of durability. It is highly available, designed for 4 nines of availability. It has very high performance. We provide high throughput, low latency performance. We also additionally provide multipart upload and range get, so you can get kind of parallelized thread performance as you query your data out of S3, querying from multiple clusters. It is very simple to use. We provide a REST API. There's also on top of that AWS SDK with many languages that would suit your need. Though Amazon S3 is a highly distributed system, and we offer highly available, we're designed for very high availability. We also offer read after create consistency, because we know that it is important for you to be able to read immediately after you create new objects, especially if you're using the data lake of querying the same data out of multiple clusters. We offer event notification, which allows you to get a notification when a new object is written into your S3, or overwritten, or delete. And you can schedule an event notification so that you get a notification in the form of a SNS notification or a topic in an SQS queue, or a third choice of triggering a Lambda function, which could be a very powerful way so you can automatically update perhaps your secondary index when a new object is put or when an object is deleted. We also offer lifecycle policy, so you can set up a policy to transition your data automatically into lower cost storage class or expire your data after the data is aged to a certain number of days. We'll talk more about this later on. S3 is highly scalable. You know, we store trillions of objects and regularly scales up to millions of transactions per second. With S3, you can store as much as you need or scale down as you need it to. We only charge for the storage you use with no minimum usage commitment. So you don't have to think about capacity planning or paying for storage that you don't need. Another powerful thing with using S3 for data lake is that it gives you the ability to scale storage and compute independently. That is very important because that means that you are only paying for the storage that you need, as well as you're only paying for the compute that you need. When you're not doing analytics on the storage, you can completely scale down your compute and not be paying for core that you're not using. Amazon S3 is highly integrated. It is part of the AWS platform of services. We are integrated with AWS Elastic MapReduce, a fully managed Hadoop service, Amazon Redshift, our fully managed data warehouse service, and Amazon DynamoDB, among many other AWS services. So let's go deeper into why the reason for choosing Amazon S3 for data lake. A very obvious reason is that it is natively supported by analytics platforms and frameworks such as Spark, Hive, Presto, and kind of the ecosystem that Raul had mentioned earlier. You can run transient Hadoop cluster and specifically separate your compute and storage so you can scale each of them independently. You don't have to pay for compute instances when you're not using it. You can also easily attribute costs for the data set and only pay for what you store. You're not running compute cluster for storage like you do in HDFS. And you can also take advantage of, for example, Amazon EC2 Spot instances as you schedule your job and take advantage of the lower cost Spot instances. A third reason why is that multiple clusters can be reading and using the same data set in Amazon S3 because your storage and your compute is separate, and that Amazon S3 offers really high performance. So you can have multiple clusters all putting and getting from the same data lake, and that is actually a very powerful reason why a lot of our customer chooses Amazon S3 as the storage layer for their data lake. Again, it is one of the big reasons why you're using Amazon S3 is because it is designed to be really highly durable, highly available, and scalable. So as you do your analytics, you don't really have to think about your storage at all. You're really just focusing on your analytics, what your analysis need to do. You can choose the best tool for the specific analysis that you need at that time, and only bring up the right compute clusters that you need for the job that you need at hand. It is also very low cost. S3 standards starts at 2 3/4 cents per gigabyte per month. So it is a very low cost storage. You only pay for what you store, and there's no upfront commitment. If your current data set is not currently in the cloud or in AWS, we offer we have been focusing on making sure that there's lots of data ingestion option for you to ingest data into Amazon S3 and to make that very, very easy. So this slide shows you kind of the wide range that we offer. I'm going to go through it briefly. For example, if you have, your data on an on-premise data center, you can choose to use AWS Direct Connect to establish a dedicated network connection from your on-premise network into AWS. If you have really, really large objects and that you're really far away from where your target AWS region is, you can choose to use S3 transfer acceleration, which speeds up data transfer by anywhere from 50% up to 400% into AWS regions. S3 transfer acceleration utilize the AWS Edge network, and we have 59 Edge network location as of today, so there is bound to be one that is close to you. This one, again, specifically, it is designed for data transferring large objects over long distances, such as across the continent or across the ocean. We also have AWS Snowball, which is our petabyte scale data transport service using a secure device. You can choose a 50 terabyte Snowball or 80 terabyte Snowball, depending on your use case. And Snowballs are available in 7 worldwide regions. We also have AWS Kinesis Firehose, which is a fully managed service to help you load streaming data into AWS. So as you can see, there is a wide range of data ingestion options to make, so that you can choose the appropriate avenue to ingest data into Amazon S3 according to your use case. So let's go through kind of the choices of storage classes on Amazon S3. As I mentioned, S3 standard is our default storage class. This is where this storage class is designed for active data. Majority of our customers would put data starting in S3 standard. You would do a bunch of analytics, especially when the data is new. And then on the other end of the spectrum, we have Amazon Glacier, which is our code archive data for the long data that you're no longer using. It is very cold. This is very, very low cost, with storage starts at 0.7 of a cent per gigabyte per month. And in the middle, this is a relatively new storage class called Standard Infrequent Access. This storage class is designed for data that is colder and less frequently accessed. And so think about the data lifecycle that we've seen from many of our customers. Generally, in the beginning of your data lifecycle, your data is really active. For example, if you have a new video or a new photo, the first couple of weeks, it will get a lot of access as you share it and you post it. So the first couple of weeks, Amazon Standard would be the appropriate storage class for this data. And then after a month or 2 months, depending on what the nature of the data, generally you will see the access pattern of those data changes, and specifically that there's much less access after a couple of months. And for that, we offer Standard Infrequent Access as a storage class that is specifically designed for data that has less frequently accessed. This is a lower cost storage class compared to S3 standard, with storage starting at 1.25 cents per gigabyte per month, although it does have a retrieval cost of a penny per gigabyte. So if you're putting in the appropriate data that is less frequently accessed, you're paying much lower storage costs. The storage cost is about 65% lower compared to S3 standard. And then over time, if you have data that is really you're just storing it for archive purpose, and you don't need the quick high performance, really low retrieval time that S3 standard and standard infrequent access offer, you can also transition that data into Amazon Glacier, which has a retrieval time of 3 to 5 hours, but it offers a very, very low storage cost of 0.7 of a cent per gigabyte per month, as mentioned. So in addition to the range of storage classes that Amazon S3 platform offers you, we also offer many of the right controls that you need in order to use this as your data lake. For example, in terms of encryption, we offer SSL endpoints so you can securely download and upload your data using our HTTPS endpoints. We offer 4 different ways of encryption, specifically 3 ways of server-side encryption. You can choose server-side encryption -S3, which is so the encryption key is directly managed by S3. You can choose server-side encryption with customer-provided keys and provide your own key. And a third way is you can choose server-side encryption with KMS. So the key is managed by the AWS Key Management Service, which provide additional auditability as well as automatic key rotation capability. And then, of course, the fourth type of encryption, you can always store on S3 using client-side encryption. We also provide a range of security features because we know that securing your data is always top of mind for you. You can use, we provide identity and access management policy, so you can establish policy at the user or group level and manage who has access to which part of the data set. You can also implement bucket policy to govern what sort of which part of the data set that user would have access to. We also offer access control lists, so you can define the access control all the way down to the object level. And if you wanted to restrict the length of time users have access to an object, we offer query string authentication, also called pre-signed URL. So you can provide a URL that is valid for only a length of time that you define. For example, 7 days or 5 days. So with that URL, a user can only upload or download a specific object for the time that you define. The third kind of pillar of control is compliance. We provide many different ways for you to, for audit reason, as well as to demonstrate compliance. We offer bucket access logs, so you can, after you enable bucket access logs, we record every API that is made into your bucket, and we would generate a log file and store that log file into your bucket. So you can use that for audit, and you can also do security analysis and demonstrate compliance with it. We also have certification that many of you need, including HIPAA, PCI, and SOC 1, 2, and 3. And I'm also going to talk a little bit about versioning and MFA delete later on in some of the slides. So to kind of make this a little bit more concrete, I want to showcase one of our customers, Netflix. They have been using S3 as the source of truth for all of their data. So in effect, they are using S3 as their data lake. And so they are storing everything that they believe is worth storing into S3. And the reasons that they are choosing S3 as their data lake is basically all the fundamentals that we've just gone through. that the S3 is designed for high durability, high availability, so they don't have to think about durability or availability of their data lake at all once they put data into S3. They enjoy having the versioning capability, which we'll talk about in a little bit. It provides them they're able to use that to protect themselves against kind of accidental delete. For example, a developer hitting delete by mistakes, that they can easily recover from it with bucket versioning. They like that S3 is highly elastic, so they don't have to think about provisioning for capacity, and they were able to quickly grow their warehouse, grow their data warehouse from a few hundred terabytes up to petabytes and petabytes without even having without having to think about capacity. And they very much they also cited the last big reason is that they're able to use S3 as their data warehouse because they're able to run multiple and highly dynamic clusters using the same data set. And that is a very powerful reason because they can scale up and down their compute as they need. So in terms of best practice, this is I want to offer you a few tips that we would recommend as best practice. First is to consider using versioning for your bucket. Versioning protects you from unintended user deletes or application logic failures. Once you enable versioning on your bucket, S3 would keep all of the versions with every upload. So when you upload a new, into the same key name, instead of overriding that object, we would upload a new version on top of the previous version. When you delete a version-enabled object, instead of removing that object, we would create a delete marker and put that as the current version of the object. So when you read the object, it would appear as if that it has been deleted. But if you decided later on that you needed to roll back or retrieve previous version of the object, you can easily do that by getting with the version ID or listing with the versioning sub-resource. So what it does, you can easily roll back and easily retrieve deleted objects. So it's a very convenient way and also protects you from any accidental deletes. The second tip is to use lifecycle policy. Lifecycle policy is a tool to manage your storage and optimize your storage costs. It enables automatic tiering as well as cost control. With lifecycle policy, there are two possible actions with lifecycle policy. First is transition. So you can set up a lifecycle policy that says after 30 days after an object is created, transition it from S3 standard into standard infrequent access. 365 days after the object is created, transition it into Amazon Glacier. And then you can also define expiration. So for example, in the same policy, you can say 10 years after an object is created, expire it. Once you just need to put this policy in once, and after that, S3 would evaluate that policy based on the policy you define and evaluate it and make lifecycle action and automatically transition and expire your object as the way that you have defined it. We give you granular control over these policies, so you can set the policy at the bucket level or at the prefix level. When you have versioning enabled, you can also set policies, separate policies for current version and for non-current version. So those, the policy that governs your current version object and your non-current version object can be completely different. So it gives you a lot of flexibility about how you will manage your storage. And the combination of those two tips is actually it gives you a recycle bin that is automatic. So when you turn on versioning, versioning creates a recycle bin for you by maintaining all the version. And then you can use lifecycle policy to define how long you want this recovery window by setting up the expiration policy for your non-current version. For example, if you want your recovery window to be 14 days, you can enable versioning on your bucket, and then you set a non-current expiration policy for 14 days. And so the first 14 days after an object becomes non-current, it will stay in your bucket. And if you need to roll back, they will be available for you. And then after 14 days, you don't have to do anything, and Amazon S3 will remove the non-current object according to the policy you set. So with the version object, we are making, as I mentioned, when you delete a version object, we're inserting a delete marker in the current version of the object. If over time, all your non-current version object has been removed, there's a potential that you would leave a delete marker as the current version while there's actually no objects underneath. So in effect, this is an expired object delete marker. If you have many of these, it can impact your list performance. So in the spirit of making sure that we give you the right tool for managing your storage, we recently launched the expired object delete marker expiration policy so that you can set a policy and lifecycle policy would automatically remove these current version delete marker after all the previous version of this object no longer exists. Setting it up is very easy. You can enable the policy with the console. It is under the bucket policy, bucket property panel in the lifecycle panel. As you can see on the screen is a checkbox by remove expired object delete marker, and it really just takes about 2 clicks and 3 clicks to set it up. It's very easy, and we recommend that as a best practice. Another best practice that we wanted to walk through is the incomplete multipart upload expiration policy. Multipart upload allows you to upload objects in a set of parts. So you can upload it. So you can parallelize uploading of an object and increase the performance if you have a very high, if you have a stable and high bandwidth environment. When you complete the upload, S3 would put the object together for you. The partial upload does incur storage charges. So if for one reason or the other your applications did not complete a specific upload, and these partial upload will continue to stay in your account, and S3 will be waiting for to hear from you to know that. To tell us that the multipart upload has completed. So in order to help you clean up these partial upload, we have launched a new incomplete multipart upload expiration policy. So you can set a policy to automatically remove incomplete multipart upload after a predefined number of days. Again, setting it up is very easy. The easiest way is to go to the management console under the lifecycle panel, and you can check a box right next to the end and clean up incomplete multipart upload. And in this example, I'm setting it up for 7 days after a multipart upload initiation. So this is once you set this policy up, we'll automatically remove the incomplete multipart upload after 7 days. And all of the partial upload storage will be removed once it becomes eligible. Other considerations for managing your data lake is that Amazon S3 uses a flat key space. So we want you. There's basically the prefix and the bucket name is completely flat. This is not a directory structure or file system. So the way we want is we want to make sure that you're thinking about how you would separate your data, so that how you would organize your data, so it would be self-documenting and intuitive. One of the ways is to use a prefix structure, and it depends on the nature of your data. A very common way is to separate your data either by business units, by application type, or time. If you organize your data this way, then it will be very easy for you to reason what type of data it is, and be able to manage that data easily. To give you an example, I have a customer who has a video use case for sports teams. So there are a few ways that you can think about how they would organize their data. One is you can organize the data by team, and perhaps team and time. Another way is they can organize their data by the nature of the video. For example, a game day video might have a different characteristics than a highlight video than a recruit video. So those are examples of kind of what are the natural data partitioning that you might consider. We want to make sure that you're thinking about how you organize the data before you start kind of hydrating your data lake. And once you decided how you're organizing your data, stick with it and make changes very carefully, because changing your structure afterwards can be very hard and costly. So lastly, we want to leave you with specific best practices for your data lake. First is we want to make sure that you are storing a copy of the raw input, so you can always replay how you're transforming the data as long as you have the raw input available. We encourage you to leverage S3 event notification and automate how you're triggering your workflow. Again, event notification, you can organize, you can trigger workflow by using a notification from SNS, a topic to an SQS as well as triggering a Lambda function. So it is very flexible, and we encourage you to think about automating using event notification. We also want you to make sure you're using a format that supports your data, because so you can always leverage how you're thinking about using your data today, as well as be able to think about how you use your data in the future. We also encourage you to apply compression everywhere, because this will make processing faster and removing the bulk of the resource from the network to your CPU. And it will just make your processing more efficient and cheaper. And with that concludes our prepared remarks, and we'll open up the floor for questions.
Great. Thanks a lot to Raul and Susan for a great presentation, and to the moderators for answering the audience's questions. If you have any comments on our previous and upcoming webinars, or topics or suggestions on the topics you wish AWS will cover in future webinars, please send us an email at aws-webcast@amazon.com. Your feedback will help us to improve our webinar programming. Thanks to the audience for taking the time to join us today, and enjoy the rest of your day.